So in this question here, we've got a pulley situation. We've got this block P being pulled along by block Q falling to the ground. Block Q has a mass of m kilograms, which we need to find a bit later. And block P has a resistance force of 1.5 newtons and its weight is 0.4 of a kilo. Now the whole thing is moving with acceleration at a rate of 2.5 meters per second squared. Now we want to calculate the tension in the strings. So the string here and here. Now the tension at both sides of the pulley will be equal and they'll be both aiming towards the pulley. Calculate the mass of Q, which we got there, time taken for this to fall to the ground, and the speed as Q hits the ground, so how fast it'll be going as it hits the ground. So first of all, let's calculate the tension in the string, and with that we want to resolve the forces in the horizontal and the vertical direction. So let's have a look at the horizontal forces. So we're looking at P. That's where we're looking at. So with P's moving along this way, so the tension that's in the rope is going in the correct direction. And the resistance force going this way is 1.5 newtons. So that's going in the opposite way, so we need to subtract it. And what we do is, as the system is moving, we use the basis of force equals mass times acceleration. So this is our forces, and we set that equal to the mass of the block being moved times the acceleration of the system. So the mass is 0.4, so we've got 2/5 times 2.5, so that's 5 over 2. So that will work out pretty neatly when we multiply that together. So that's at P. Now, what's going on at Q as this falls to the ground? Now here we can calculate our tension, but I'm just going to note my forces as I said what's going on at Q. So at Q, we've got tension going in the opposite direction, but the mass of the block Q is going in the right direction as gravity falls on that. So that's going to be plus mg. And that equals mass times acceleration. So that's the mass of the block, which is m, acceleration is 2.5. So that's 2.5 m. Okay, so now this one we can solve for the tension straight away. If I bring, this is just going to bring, multiply to 1, minus 1.5 over the other side. So that's going to give me tension of 2.5 newtons. So that's straight away solved. So that worked out quite nicely. Now we want to work out M. Now here we've calculated tension, so we can substitute that into our calculations here. So we've got minus 2.5, as the T is minus, plus M times G, and that equals 2.5 M. Okay, well let's just move around these values here a little bit. Let's bring the 2.5 over this side and bring this over here. So that's going to be plus 2.5, so let's go back into fractions. Got plus mg, so that's going to be plus mg. So g we know is just a number, that's going to be 9.81. And the 2.5 here will be a negative, so minus 2.5 m. So then if that's 9.81 and that's minus 2.5, we can have 9.81 minus 2.5, which will leave us with 7.31 m equals 5 over 2. And now all I've got to do now, divide both sides by 7.31 and I can isolate my m. So m will equal 5 over 2 times 7.31, that'll give me 14.62. So then if I plug that into my calculator, 0.342 kilograms. So 342 grams will be the weight at M. Now the next bit, we want to find the time taken for Q to hit the ground. So now at this stage, these bits are done, we've calculated our forces. So with a constant acceleration, we're into a situation now where we need to use our Suvat equations. So with this situation here, I'm just going to write my 5 possible components and see what I've actually got. So time taken for Q to hit the ground. Well, the distance to travel is going to be 2 meters. So S is my displacement of 2 meters. Initial velocity, well, it's going to start from rest, so that's going to be 0. The velocity as it hits the ground, well, that's what we want. Acceleration, we know, that's 2.5. And time taken, well, that could also be something else we need as well. So velocity and time is something else we need here as well. So we need those two components. So which one can we work out first? Well, I've got S, I've got U, I've got A, and I've got a V missing. And I've also got a T missing. So I've got a combination of equations I could use here. So first of all, perhaps find the time. So the equation I can use for that is going to be S equals UT plus a half AT squared. And I've got enough I can plug in there to try and solve for T. So S is 2. U is 0, so that all disappears. Then I've got a half. Acceleration is 2.5. And then I've got T squared. So then what have I got here? I've got 5 over 4. So let's simplify that over. T equals 5t squared over 4. So then if I multiply this side by 4 and divide by 5, so then I'll have t squared equals 8 over 5, and then t will be square root of that. So t equals square root of 8 over 5, and if you plug that into your calculator, you get approximately 1.26 seconds. So approximately 1.26 seconds. So we can put that in there. And we can say we've answered it here. Time taken to the ground, 1.26 seconds. Now we need to try and calculate the velocity. Well, as we've got the other 4, should be choice of equations we can use to try and solve for velocity. So the one I'm going to use is the simplest one, V equals U plus AT. And we've got U, we've got A, and we've got T, so we can solve for V. So therefore V equals 0 plus 2.5 times our time T, which is the square root of 8 over 5. So keep that. So with that now, we can try and calculate our exact value for our velocity. And let's try and do this without a calculator. So our velocity is 0, so ignore that. 2.5, so let's just write that as 5 over 2. And then times, let's break this into 2 parts of its fraction, root 8 over root 5. And then now let's turn this into 1/3 if we can. Square root of 5 squared is 25, so that's square root of 25 times the square root of 8. And then here we've got 2, which would be square root of 4 times square root of 5. And then 25 times 8, we can do that. That's the square root of 200. And root 4 times root 5, square root of 20. So now we can just divide and we get the square root of 10. And that's nice, neat, straightforward answer. And then square root of 10 is approximately 3.16. So root 10 is approximately 3.16. So their speed as it hits the ground is approximately 3.16 meters per second. And that completes this question.